Here's another cool question that a student asked me. Do you think your work will justify itself by the end of your lifetime? Wow. So, I mean, famously, mathematics is not necessarily going to be used during the lifetime of the mathematician who invented it. And we know, for example, that a lot of number theory was developed by mathematicians prior to computers, and at the time there was no use really for number theory. But what does it mean to justify? I'm sure that a lot of these mathematicians who proved stuff about, like for example, who proved that that there are infinitely many prime numbers. It was proved by Euclid. So thousands of years ago, he proved that there are infinitely many prime numbers. And since then, number theory has obviously been developed to a very complex degree by Riemann and Euler and other mathematicians before computers. And there was no use. I mean, who cares how many prime numbers there are? Infinitely many, or just 25 billion of them. From the practical perspective, hardly any difference. But mathematically, that's very interesting because our understanding of the mathematical universe and already kind of got refined, and our understanding of mathematical techniques and mathematical proof concepts and the whole like concept of natural numbers really depends on the fact that there are infinitely many prime numbers. And then there were obviously like a lot of developments in algebra because of these kind of ideas and so on and so forth. In many ways, mathematical ideas are justified by already like the fact that they are interesting to other mathematicians. So fine, okay. On the other hand, we know that after the Second World War, when computers became popular and cryptography, the secure encryption, and today cryptocurrency, everything is based on number theory one way or another. So all these encryption techniques and you name it, let alone connections between number theory and analysis. Today, it's all very complex and advanced, and number theory has certainly justified itself not only within mathematics but also in applications. Now, when it comes to me, I have done different types of mathematics. In my PhD thesis, I was working on something called generalized descriptive set theory. That's very, very, very abstract. It deals with uncountable sets. So I have not uncountable sets like real numbers, but like uncountable sets like very, very, very large sets. Also dealing in particular with large cardinals. If you guys are interested in Googling what's that, a large cardinal. That. And that theory, I mean, it justifies itself by existing at this moment, but as something that will ever be used in any like how should I say, either application or some kind of very fundamental breakthrough even in other areas of mathematics which are more close to real world, like analysis or even number theory or something like that. I don't think that in my lifetime that will be in that sense justified. It certainly is justified already because other people working in that area are using my results. So in that sense, it's justified. But whether that area itself is justified, I don't know. I mean, depends what you mean again. Right? So in terms of being used in rocket science or anything close, robotics, No, I don't think that the details of the work that we've done are going to be justified during my lifetime. However, I learned a lot from doing that. And now I am working with roboticists, developing mathematics for robotics, and that work I hope will justify itself even on a very practical level, because my dream is to also build business with robots and develop and so that my mathematical solutions are actually going to be using algorithms and AI very soon. So yeah, in that sense, I hope that not only during my lifetime, but much sooner, these things are going to be put put to work, so to speak. Thanks for the question.